Moving on to Physical Science Module 12B, we'll be talking about photons and more about electromagnetic force. Our vocabulary: photon, charging by conduction and charging by induction. So electromagnetic force is produced through an exchange of particles. We've talked about this exchange in a previous module. This exchange can generate an attractive force or a repulsive force. The particles are small bits of light, and the bits of light are called photons. A photon is a small package of light that acts like a particle. Most light in creation is invisible to the naked eye. It is rare to actually see the exchange of photons by charged particles. However, all the light we do see is the result of an exchange between two charged particles. The lights in our homes send out photons resulting from interactions between charged particles. A light bulb produces light by first producing heat. Then the heat comes from an electrical current that warms up the filament in the light bulb. Electrons in the filament begin to move around, and once the electrons begin moving, they exchange less electrons. So that means they have more when they first begin to interact, and then they have less as they go. That's because they're shedding electrons. As a result, extra photons are ejected, and we actually see those extra photons as a white light. So in previous modules we talked about the exchange of positive and negative charges. In this case we're talking about photons as those charges and being charged particles. And when photons are released, we can actually visualize them as white light. The more charge a particle has, the more photons it can exchange. So, consequently, the magnetic force between charged particles is directly proportional to the charge of the particle. So, once again, the more charge the particle has, the more photons it can give away. So how do objects become electrically charged? Well, let's take a look at this sodium atom. It has an inner ring of 2 atoms of Na, which is sodium, a secondary ring that has 2, 4, 6, and 8, and then there's a third ring that has an electron on this third ring. That electron is lost, and when that's lost, the atom actually becomes a sodium ion with a positive charge, and it only has these 2 rings, or 2 shells as they call it. So in the beginning, atoms are electrically neutral. They're composed of, and this is a review, neutrons, which have no charge, protons, which have a positive charge, and electrons, which have a negative charge. Atoms that lose electrons become positively charged, and then we call them positive ions. Atoms that gain electrons become negatively charged. We call those negative ions. One way that atoms gain or lose electrons is through chemical reactions. Now, we don't go into chemical reactions in this course, but chemical reactions are governed by rules to keep the atoms balanced. And so whenever an electron is shared or lost, there's a process for balancing the atoms. There are other ways atoms gain and lose electrons. there was an experiment in our text, experiment 12.2. And in this experiment, we had a balloon that was blown up, and it was negatively charged. And then we had a coil of wire. Attached to the coil of wire were two pieces or strips of aluminum. And they were balanced originally with negative and positive charges. And when brought in close proximity to the paperclip, or this coil, the negative charge of the balloon repelled the negative charges in the coil, in the aluminum foil. Since the charges were repelled, they traveled away from the balloon, which caused the ends of the foil to be rich with electrons. The excess of negative charges in the foil strips caused each strip to become negatively charged, and that made the strips repel each other because now they were both negatively charged instead of being balanced. So consequently, they end up pulling apart during the experiment. So the negative charges actually traveled in this process and converted the balanced aluminum foil strips into negatively charged strips. The foil and the paperclip or coil have both positive and negative charges. The charges are balanced, so there's no overall charge. The balloon picked up some electrons from our hair. The balloon then had an overall negative charge. So originally the balloon also started off as having no overall charge. But because it interacted with our hair, it picked up electrons and became negatively charged. So when the balloon came close to the wire coil, which was negatively charged also, the charges were repelled. So the wire coil was actually balanced before the balloon came to it, and it became negatively charged because we now had two negative charges. One from the balloon, one from the coil. The charges were repelled. The charges moved away from the object, so they traveled to the foil strips, and that caused the wire coil to become positively charged because it had shared its electrons, and the foil strips become negatively charged because it had received electrons. When you charge an object by touching an electrically charged object to another electrically charged object to it, and allowing the charge to flow between the two, physicists call this charging by conduction. So charging by conduction is when you electrically charge an object and you allow that charge to flow. So what happens when something is charged without an electrical object touching it? The first part of the experiment had an electrical charge from the balloon that caused a flow. In the last part of the experiment, the foil strips became positively charged when a person's finger was placed on the coil and actually removed some of the electrons. So the electrons were attracted to the finger, and now those what had been negatively charged foil strips became positively charged because electrons were removed. The strips then, because they were both positively charged, repelled each other. So we had a situation in the first part of the experiment where they were repelling each other because they were both negatively charged, and now in the second part they're both positively charged with the same result. So in this part of the experiment, we removed some negative charges from the foil. This was called charging by induction, and that's charging an object without direct contact between the object and an electrical charge. So the first one, conduction, is when you charge an object with an electrical charge, and induction is when you charge an object indirectly or without direct contact. We'll be moving on to the next part of the module. We'll be talking about electrical circuits, and if you have any questions, please contact me.